All right, let's go on to comparison of fractions. What I'm going to do is I'm going to give you a series of rules for comparing fractions at the end of this. And in most cases, you'll be able to look at two fractions and be able to determine which one's larger, which one's smaller. Okay? In most cases, it'll be a visual. We start out to here. We're going to go to a party. And at this party, we have a chocolate cake. Okay? It's mine. You're going to like this. I'm going to tell a little story, and then we're going to get on to the other aspects of the comparison. So at this party, we're going to have two scenarios. Okay. Now the first scenario, we've got a guy. He's at the party. He sees this chocolate cake. You know. His name is 10-Ton Teddy.
What?
10-Ton Teddy. Now 10-Ton Teddy, he hasn't missed too many meals, not too many snacks either. That's why they call him 10-Ton Teddy, right? Who's in this party? He sees this cake. Now he knows he can eat all of that chocolate cake, right? He doesn't want to eat it all and make a pig of himself. Everybody gets mad. I mean, the big guy ate all the cake on us. So he wants to devise a little scheme here to sort of trick everybody. So what he does is he calls over one of his friends, 9-Ton Ned. So him and 9-Ton Ned, they're going to go over here and eat this cake. That was his plan, right? So how many friends are going to be eating the cake? Two. What are we going to put in the denominator?
One.
2. Number of people eating the cake is the same as the denominator. And how big of a piece are they going to get?
Half.
Approximately like that, right? Right, give or take?
So green.
All right, now 10-Ton Teddy starts to think. He says, well, geez, if I blame 9-Ton Ned and he blames me, there's not enough deception there. Let's call someone else here. Sort of get a little triangular confusion going here. So who does he call? 8-Ton Eddie. So here comes 8-Ton Eddie. How many people are eating on the cake now?
3.
What are we going to put in the denominator?
3.
And the size is going to be, I'm going to change this around here a little bit.
So 1/3 of each.
And let's try doing it like this. Oop, can't do it that way. Let's go like this. Approximately like that. Let's go to scenario 2. I'm going to call this 10-Ton Teddy. Call him TTT. Over here, we got anorexic Ann. Anorexic Ann, she's real skinny, very skinny. Yeah. She looks at this chocolate cake, and just like 10-Ton Teddy, she figures she could eat the whole thing. But she doesn't want to gain too much weight. She wants to keep that slim figure. So what does she do? Well, that's bulimic Betty does that. So what anorexic Ann does, she calls over 7 of her friends.
Okay.
Okay. How many people are eating on the cake now?
4. 8.
8. And what are we going to put in our denominator?
8.
And
That's all I'm trying to figure out.
the size is now going to be approximately like that, right?
I'm sorry, how do you 8?
2, 4, 6, 8.
Anorexic Annie
And 7 friends.
Oh, okay. I didn't hear you say that.
You can just eat it. Just go on.
Or anorexic Ann looks at this piece and says, well, geez, I still can gain a lot of weight from this piece. So she calls over 8 more friends.
Oh, jeez.
How many people are eating on the cake now? 16. And what's going to go in our denominator? 16, because there's 16 people eating the cake. We're going to have 16 pieces of cake. Now, let's change this to 16 pieces. So we're going to go something like this. now anorexic and it's a piece about that big. Now when we look at this, what do we know between the correlation between people eating on the cake and the denominator?
Larger
The
the
bigger
number,
denominator,
the
the
smaller.
smaller the
The
piece.
more
Yeah.
people, it's the smaller.
The more people that eat the cake, the smaller pieces we're cutting it into, right? The smaller portion size they get. So here, when we see 16, or they're having one of 16, one piece out of 16, they're getting a very small piece. Anorexic Ann kept inviting more friends over. She wanted a smaller piece. 10-ton Teddy, he just wanted a little confusion. He didn't want to eat the whole thing, but he brought few friends. So the smaller the denominator, actually the larger the piece, right? This is the opposite of what most people think of. Because as the numbers get larger, usually the value gets larger. In a fraction, as the denominator gets larger, the portion or proportion gets smaller. That's a key concept to remember. Okay? So remember, 10-ton Teddy, few people, a very low denominator, a very large portion size. Anorexic Ann brings over a lot of friends. Larger denominator, very small portion size. Key concept.
I like that one.
How does this relate to comparison of fractions? Let's go to there now. Everybody good on this?
Yeah.
All right, here's our rules. I'm going to take two fractions. I'm going to take 1/8 and 1/16. We notice here that the denominators are the same. We'll go back to that example of 10-ton Teddy and anorexic Ann. If this is 1/8 and this is 1/16, which one is smaller? 1/16, right? All right.
This cake, yeah.
Yeah. The portion size is smaller because there's more people eating the cake. This is the anorexic Ann scenario. Let's write a rule for that. Let's say if all right, rule 1 says, if the numerators are the same, that's the case we have, they're both 1. The larger denominator, in this case the 16, is the smaller fraction, or the smaller portion size. Okay. Everybody clear on rule 1? Makes sense, doesn't it? We just illustrated in that previous story that we had. Let's go to 2. Let's switch this around. In this case, we have the denominators are the same, but the numerators are different. What this is saying is we have that, let's say, chocolate cake. We cut it into 8 pieces. This person took 3 of the 5. This person, 3 of the 8. This person took 5 of the 8. Who had more? 5 of the 8, right? Let's come up with a rule. Okay. Rule 2 says, if the denominators are the same, They are the same. We're going to look at the numerators. The larger numerator is the larger larger fraction. So 5/8 is larger than 3/8. If you want, you could say if the denominators are the same, the smaller numerator is the smaller fraction. It works either way. Okay? Well, we got the scenario if the numerators are the same. We got the scenario if the denominators are the same. There's only one other scenario left. Everything's different. Over here we got 3/4, we got 5/8. Well, we know that 4 goes into 8, so we can get a common denominator here, right? So I could convert 3/4 into 8ths by multiplying both the numerator and denominator by 2. So 3/4 is an equivalent fraction to 6/8. So I can say 3/4 equals 6/8. Everybody follow me? Who said no? I took 3/4. I know 4 goes into 8. If I multiply it by 2, multiply the numerator and denominator by 2, I got 6/8. So 3/4 is equal to 6/8. Now I compare these two fractions. This falls under rule 2, doesn't it? Because the denominators are the same, the numerators are different.
So you have to change, not simplify it, make it larger, are you saying?
Find the common denominator. And then use rule 2. Alright?
So the 6/8 would be larger than the
Yes.
5/8.
This is larger than 5/8.
Right.
Or if you want to go in which one's smaller, the 5/8 is less than the 6/8.
Okay.
Either way works. So let's have a rule here so we know what to do. Alright, so here's what we're going to do. If the numerators and denominators are different, such as the case over there, find a common denominator, which we did when we converted 3/4 to 6/8, and then go back to rule 2. Mo?
Would you be able to make another example of that?
Yeah. No problem. I'll just give you a minute to copy this down, and then I'll do the next example. Matter of fact, I'll help. Let's try 1/8 and 3/16. Well, what do you think we should do? Yeah. When you're finding a common denominator, see if this divides evenly into this denominator. Since 8 goes into 16 evenly, right? So we could change this, the 8ths, to 16ths as an equivalent fraction. What we're going to do is multiply the 8 by 2, that gives us 16. Let's multiply the 1 by 2, we're going to get 2. So 1/8 is equal to 2/16. Now we compare these two. Which one's larger, which one's smaller?
3/16.
3/16. Go back to rule 2.
Happens when you have a whole chain of,
You have a whole chain of them.
yeah,
No problem.
like. You should do that now before you see the test.
No, right?
7, 8.
Let's look at this. We got 4 fractions there. Incidentally, Dave wanted this problem. All the numerators are the same. It doesn't matter what value it is. Which one's the largest, which one's the smallest?
Largest is the 100,
The
smallest.
smallest.
smallest is
100.
And 1 over 100.
The largest would be 125.
Largest, smallest. Right?
Yeah.
This is anorexic Ann, bringing more people in. 10-ton Teddy. It's a bigger cake.
So we don't have to find that.
No,
'Cause we
follows one of the
already-
rules.
Okay, yeah,
Remember, it's a visual almost.
yes,
No calculations required.
okay.
The only time you're really going to do any computations is when you get to here.
Okay.
If it falls within these two rules, it's a visual. So 2/3 of the problems, if they fall within those, you're going to be able to do via visual. As long as you understand the rules properly. Does it seem difficult?
No.
Yes? I think after you do a few, you'll get it. Everybody good?
So we can even have, like, 7/8, 2/3,
All right, let's see.
quarter, 1/8. Yeah,
7/8, 2/3.
yeah, quarter, 1/4. 9/2.
What's that?
9/2.
9/2.
Yeah, if it's a mixture of a number and then you turn it around like that.
All right. That's an improper fraction. Okay. Dave's got an interesting problem here. He's got a series of fractions, of simple fractions, then he's got an improper. But we know these are less than 1, this is greater than 1. So if we want to know the larger, this is definitely the largest. Right? It's greater than 1. All of these three are less than 1.
Because it's an improper factor.
Yes. Okay. If we want to find the largest, we're done. If we want to find the smallest, we've got to find a common denominator. Well, what is the common denominator?
8. Wait, no.
Two.
24.
8 doesn't go to 12 evenly.
4.
24. All right, so let's change 7/8 to 24ths. Multiply this by 3. 21 24ths. So this is equal to 21 24ths. What about 2/3? Have to multiply by 8. It's 16. How about 1/4?
6.
Have to multiply that by 6. It's 6 over. All right, so now we got all these 3 and 24ths. Which is the largest, which is the smallest? 1/4 is the smallest, yeah. This is only 6 24ths, this is 16, this is 21. So if we wanted to put these in order from largest to smallest, what would we do?
No, that can't be right.
Ascending order.
Largest to smallest? Okay, 9/2.
That's the largest.
That's
1.
7/8, right? 21 24ths. Then 2/3, right? 16/24, and the smallest is 1/4, which is 6/24. Make sense? Dave up the ante on us.
Yeah.